In this final lesson of this unit, we are going to look at solving composite area problems. So in these problems, you are going to have shapes that are made up of other shapes to form these irregular shaped polygons. So the easiest way to tackle these problems is to divide these shapes into their parts and try and form rectangles or triangles or circles so that you can find those areas separately and then use addition or subtraction to combine them or find the difference between them and solve for your composite area. So if you look at this very first example, we've got this shape here, and you're looking to find the area of it. The easiest way to do this is to divide this into two rectangles. Then you can see that the area of the first rectangle would be 20 times 15, just 300 square centimeters. The second rectangle would be 15 times 15, which would be 225 square centimeters. Then you just need to add them together to get the total area. If we look at example 1, we've got this shape that sort of looks like a house. So again, we can first find the area of the triangle, which you can see on top. So for the triangle, the area is base times height divided by 2, which in this case, the base of this triangle is the same length as the base of this rectangle here. So this is going to be 6, the height is 2, and divide that by 2. So the area of that triangle is 6 square meters. If we look at the rectangle, remember the area of a rectangle is just length times width. So that's going to be 6 times 5, which is 30 meters squared. So if we want the total, we would just add 6 plus 30 to get 36 square meters. If we look at this next shape in example 2, it says Dean is cutting a new countertop. It's asking you how many square meters of laminate are required for this top. So if you look at this counter, you'll see that we've got two rectangles. The first rectangle could be this top part here. You could also divide this rectangle in this direction. Either or, it doesn't make a difference. So I'm going to call this rectangle 1 and this rectangle 2. So the area of rectangle 1 is just going to be the length times the width. So 3.2 times 1.9. 3.2 times 1.6, sorry, 1.6. There we go, so 5.12 meters squared. Now the area for this second rectangle, we need the length and the width. We see the length is 0.9, but we need to figure out what this width is. And if you notice here, this entire width is 2.9, and this part here is 1.6. So in order to solve for this length, we would take 2.9 and subtract this portion that we already know to be left with 1.3. That's going to be the width of this second rectangle. So here we've got rectangle 2, which is 0.9 times 1.3, which is 1.17 meters squared. So to find the total, we would just add those up. 5.12 plus 1.17 to give us a total of 6.29 meters squared. If we look at B, it says if the area of a sheet of laminate is 12 meters squared, how much of the sheet is going to be wasted? So the total area is 12 meters squared, but we only need 6.29. So if you subtract 12 minus 6.29, the area that's going to be wasted is what's left, 5.71 meters squared. And if the cost is $10 per meter squared, how much money is wasted? So this is the wasted material, 5.71 meters squared, and it costs $10 per meter squared. So $10 times 5.71 is $57.10. That would be wasted. If we go to the next page, you can see here that these look a little bit different. In the previous examples, we were always adding, so we would find the measures of two shapes and then add them together. In these ones, you'll notice here that we could use subtraction. So in this case, if we're looking for the area of the shaded region, we could find the area of this whole rectangle, and then find the area of this little triangle that's being cut out and subtract it to see what's left. So if we start with the rectangle, its area is 20 times 12, which is 240 square inches. But if we remove this triangle, its area is base times height. Well, we can see the height is 6, but we don't exactly know what this base is. But if you notice, the entire length of this rectangle is 20. This little piece is 8, and this little piece is 8. So we can figure out what's in the middle by using subtraction. 20, take away 8, take away 8, which leaves us with 4 inches. So for the triangle, the base is 4 inches, and the height is 6 inches. And we divide that by 2. Base times height divided by 2. So in this case, it has an area of 12 square inches. So if we're looking for the total area, we've got 240 minus the 12 inches that are cut out, so 228 square inches would be the area of the shaded part. And finally, in example 4, we're looking for the area of the shaded region. Well, this is just a circle inside of a square. So if we start by looking at the square as a whole, and you want to start with the whole shape and then remove or subtract the part that's being removed. So if we look at this whole square, we don't have a lot of information, but you can see that the radius of the circle is 12, and we know that this radius is exactly halfway. That means that if I drew another radius in this direction, this would also be 12. And that means that the total length or width of this square is 24 centimeters. So if we look at the square, the area is 24 times 24, or 24 squared, which is 576 centimeters squared. And the area of the circle, remember the area of a circle, I'll write out the formula for this one since we haven't used it as much, is pi r squared. So pi times 12 squared, or pi times 144, which is equal to 452.39 centimeters squared. So if we want to know the shaded part, we take the whole square, which is 576, and subtract this circle, 452.39. And we're left with 123.61 centimeters squared. And that is how you work with composite area.